Hello, this is Dr. Josh Silver, and today we will be going over how to do an upper cervical orthogonal based analysis of the cranio-cervical junction for any upper cervical type technique using the upper cervical toolkit. And so the upper cervical toolkit you can see here in the bar. If I open it up, it is a digital overlay tool with all of the most commonly used tools for the practicing upper cervical doctor. If you haven't seen my other videos on Toolkit, please check it out. So, to begin my analysis, I need to remind the viewer that we're going to be doing two things. We're going to be using the toolkit to measure our misalignments, but we'll be positioning the imaging first in our viewer of choice, and I prefer Radiant, especially if you're doing a 3D analysis. Radiant is particularly useful because two main points. Number one, this scalpel tool I really like allows you to scalpel off different parts of the skull to allow you to see things easier if you need to. But more importantly is this coordinate viewer. And so right now it's saying that our image is rotated 69.6 degrees to the left and it's S to I 10.7. And it just really allows you to keep track of where you are in space. And right now we're at 0, 0, 0. So anytime I get lost, I just hit this refresh and I am back to 0, 0, 0. And so to begin our analysis, the first thing I need to do is unrotate my image. And you can see that she's kind of looking off to the right. And I can tell because there's a lot more skull showing here, there's less here. This mastoid's under the jaw and this one's sticking out. So I can use the arrow keys to start to rotate my image. And the first thing I actually check is the jaw. Right? I want these jaw lines to superimpose, and so this one's not on top of that one, but they do become superimposed when we're at -3. So I kind of assume that -3 is a good starting point, and I rotate the image so I'm at -3, which would be right there. See, that's the utility of that map, that coordinate. And so this should be a fairly unrotated skull, and in traditional methods we would measure the lateral canthus to the outside of the skull to see if our frontal is rotated. And you know what, this one's considerably larger than this one, so I actually may take it one more degree that way. And now it should be closer to symmetrical. And they're perfect. So we could just say, we're done, our frontal is unrotated, but I also kind of like to pitch it down, and then we can look to see, does that line up with that? And so this is our first application of Toolkit, right? Is if we open Toolkit, just by clicking it, Alt-Tab will bring us back to Radiant, Alt-Tab will open Toolkit. I just hit those all day. But if I drop the vertical angle right through the middle of that, and right through the tip of her nose or the middle of her head, whatever I can see, I mean, that's pretty straight. That's not really rotated. So I'm going to assume that at -2, she's unrotated. And that's going to be our reference point for a lot of our measurements we do in 3D. Before we move on, I just kind of wanted to take a sneak peek inside her foramen magnum. And again, cone beam is such a wonderful tool because it allows us to do things like this. It really looks like her atlas, like that posterior, or posterior on the right and anterior on the left, kind of what I'm looking visually. But also I see a little bit more mass here of the atlas and more tucked in over here. So we're going to actually say, So we're actually going to think that this atlas looks like it's more of a right lateral since it's tucked under here. And I don't use this firmly, but it is one way to think about your measurement. So let's bring it back down till we're at a 0 degree rotation. As the I is back at 0, we're at -2. There's no rotation in the skull. And to see a perfect, well, let's measure head tilt. Now, it's a little not necessarily as precise as we're used to. I just try to drop it between the teeth and straight down the middle of her head, right down the middle of the sinuses. If we jump back to radiant and fill in her density, does that go through the middle of her head? It looks like her head's tilted to the right by 1.1 degrees. And so we can pop that in on a head tilt to the right by 1.1 degrees. But if you're more picky than that, I have a lot of friends that will measure more of the orbits, right? What's the head tilt according to the orbits? Looks like that's about a 2.6 degree head tilt if you choose that as your measurement point. Sometimes I like to go right on the zygomatics. That actually aligns fairly well with what we just measured. I wouldn't really measure the mandible because that can be shifted or misaligned. But I like to use this to try to find how much my head tilt is. And that is the first measurement we need. The next thing we need are our plane lines. So, since we know -2 is unrotated, then if we rotate this to 178, this is going to be a perfect posterior to anterior view of her. And I'm just going to go ahead and grab a snip of this, because I like to have these on my listing card. Okay, if we use the arrow keys, I can tilt my image now. And what I'm trying to do is get the anterior arch of her atlas and the posterior arch of her atlas to superimpose. So we're going to continue tilting those until they do match up on top of each other. And that is going to be our traditional down the plane line of the atlas view that we usually take in our x-ray. We're just looking at it from the back. So I'm going to go ahead and start positioning this image for measurement. And we will once again activate the toolkit. And the horizontal angle tool I will place just above and lateral to the joints I wish to measure. And then I will use my arrow keys to start to drop it down on top of those joints. And since it's dropping and hitting the right side first, I will use the other arrow keys to add more tilt and just try to drop it on both of those at the exact same click. So that's going to be the tilt of her atlas on the superior lateral mass. We can do the same thing for her inferior lateral mass. Let's start moving that up and tilting it into position using the arrow keys, right and left. And that is what I am measuring for her inferior lateral mass. So if we open up the main calculations, make sure that you know that this is her right side. Her atlas appears to be high on the right on the superior lateral mass by 2.09 degrees. 2.09 degrees. And the inferior one appears high on the right by 3.03 degrees. And as done in previous videos, the way this calculator is dealt, it will use this measurement tool on top of the atlas to measure the upper angle, and this tool on the inferior lateral mass to measure your lower angle, and it will calculate the average to make a working plane line. So let's see this in a different language. We have a head tilt to the right of 1.1, and it's high on the right of 2.09, so that gives her a laterality of 3.19. We need to measure her cervical spine, her C/A, her rotation, and her spinous, so let's get to work. If we jump back here and reset the image, we're going to take it to the lateral side. Roughly lateral. And at this point I choose to use the scalpel tool to amputate the posterior arch. We can bring it back whenever we want, but if we now bring it back to our perfect posterior to anterior view, which we knew was 178 on the coordinate system, and zoom in until you're ready to measure that cervical spine. If we open up the Toolkit, the center point tool, I will drop it on both sides of the dens. But it's in yellow, I can't see that. Let's try this in, why don't we say green. There we go. And I'm just going to center point the heck out of her neck. I just like to pick symmetrical parts of the vertebra, if I can. You can see that this joint's a little slipped, so we have to be careful marking these. And oftentimes I'll trim off all of these facets and spinuses so I can see right into the neural canal as well. But if we drop our vertical angle tool, put it right over the center of that dens, and right over the center of the center points, looks like her neck is tilted to her left by 1.26 degrees. So let's open up the main calculations. Cervical spine tilted left 1.26 degrees, and it will take that measurement, compare it to my inferior lateral mass to calculate my lower angle. The average between those two is my plane line. We need rotation, C2, our C over A, and our angular rotation is automatically carried over from our cervical spine tilt measurement. So, let's measure some rotation. Reset the image, and how I like to measure my atlas rotation is by bringing my image straight posterior at 178. I'm going to zoom in on my upper cervical region, and I'm going to start to tilt the image until I can see straight through the C1, C2 joints. So if we tilt, 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 now I can see through that joint very clearly on the right side of the image. And I'm going to scalpel off everything below the atlas, coming right through that joint space, but not cutting off any atlas. Then we want to cut off the other side, C2, and everything below it. Let's make sure we also cut off the rest of the neck below C1. And at this point, all I have to do is rotate my image till I get a horizontal view. And this is how we're going to be measuring rotation, right? We've already established that the skull isn't rotated. We already took the rotation out. So all we need to do is compare that atlas to that. So in the toolkit, all I do is horizontal angle, and if we put it right on top of the atlas here and here, we should see that this atlas is anterior on the right side by 1.63 degrees. Or, of course, you can do more of my drop it right on the cake technique. So, you'll always get different measurements, even if you do the same scan over and over again, because when we're measuring to 100th of a degree, it's bound to be different. 1.39 anterior on the right, we will enter that in here. And what it will do is say, oh, this atlas is a right, so this is an anterior. But if the laterality turns out to be a left, it will automatically flip that to a posterior rotation. Do not worry about that. For our C2 rotation, let's reset our image once again and take it from a lateral perspective. And this time we're going to do a scalpel where we scalpel off everything below the atlas, the C2 body included, but we want to leave the top of the dens in there. We're going to scoop now under and leave the C2 spinous in there, but we're going to cut off C3 and C4 and anything below that. If I take my image back straight to -2, where she's no longer rotated, and I hit the up key, I can see a straight I to S perspective of the dens and the spinous. So we will measure her C2 rotation in relation to the screen, which we know is unrotated. I'll use my center point tool over that dens. Drop a vertical angle tool right on the center of that dens and over the center of the C2 spinous. And we can see here that this woman's atlas, or C2, has a kick off to the right side by 3.73 degrees. Okay, this is the left side. Vertical is square. Her C2 spinous is off to the right by 3.73 degrees. So if we put it in here, C2 spinous is off to the right by 3.73 degrees. We have nearly all of the measurements we're going to need except for our C over A. And I definitely prefer to do the C over A measurement in NPR, but it is possible to do it in 3D. The best way to do it is to bring the image lateral and then scalpel the entire skull right through the middle of C1 and C2 and the whole front of the face. If we now bring it straight A to P, which was -2, there is our C over A in 3D. Now I'm going to tilt the image so I like where I'm measuring it a little bit better. Drop in a flat line holding the shift key. Opening up your toolkit, Euro, and calibrate that line. When you hit the calibrate button, you can put this line over this and teach the tool that this length it sees is 2.51 centimeters and enter that in. Condylar tool, I'm going to drop 4 points all on the weight-bearing surface of the C0 joint. And for the axial circle, we will measure it over the top of our axis. I don't really like that. You know what, we're going to go with it like this, since we can see more C2 over there. There we go. That looks much better. And so now we have our condylar circle here as a 3.4, and our axial circle as a 4.1. And if I hit the auto load button, they just pop in beautifully right there for us. You should now have all the measurements you need to do your assessment, and you can change the language if it is necessary. I would definitely click Save Measurements at this point. And that is pretty much it. Last thing we would need in this case, of course, would be a picture of the right transverse process so we know where to aim our machine. And so if we bring this over to the right side of the image, let's just clean that up first. Zoom in on your transverse process. Open up snipping for the toolkit and freehand out that mastoid. Freehand that transverse process. And freehand the jaw. I'll jump back into Radiant and fill in the density until I can see the skin. Looks like I trimmed a little bit of earlobe off by accident. But that is where her transverse process is relative to her earlobe, her mastoid, and her jaw. And I will grab a snipping of that and put that picture onto her listing card. That's about it. You can get lost in these. We will definitely be changing the analysis as we learn more, but I created a need for the upper cervical doctor to just try and get a quicker measurement system here. And this has been working really, really well for me. So if you're interested in switching your practice to cone beam or utilizing the toolkit as an assessment, please go to advoaccessories.com in the link, and we can get you a free demo of the software for 7 days, or you can buy a permanent lifetime subscription if you wish. I hope this has been helpful, and thank you for watching.